Hi students, today we're going to start to cover chapter 3, data preprocessing. And I think we mentioned earlier that data preprocessing is a critical step in any data mining tasks because in vast majority of cases that data we received won't be perfect. There are plenty of things that we need to do to make the data in the right format of a good quality to support our data mining tasks. So in chapter 3, we're going to cover the following topics listed in this slide. We will start with an overview of data quality dimensions. What are the things we should look at when we assess data quality? And we're going to briefly talk about the data format, wide and long format, tidy data, and what would be the best way for us to format our data so that it's easier for us to perform data mining tasks, run different algorithms. In data pre-processing, there are some major tasks, 4 major tasks that typically we will perform. And then we're going to actually talk about those tasks and the methods to complete those tasks or address those tasks one by one. The organization slides for this week is different from the organization used by the book. I do recommend you to read the book and then look at the slides. We cover the similar things, but I just feel like my organization may be a little bit cleaner or clearer, but that's probably my biased view. The truth is this chapter we're going to cover a lot of things, so you can feel dizzy. It's all right if you feel dizzy. And we will not be able to cover everything in chapter 3 in one lecture, so we're going to split it into 2 weeks. Learning objectives, remember those? Please do come back and check your learning against those objectives. If you do have questions and feel like yourself is sort of uncertain on certain aspects, do please post questions and also use the quiz to assess your learning. So next we're going to dive into the content and we're going to look at the dimensions of data quality. So why pre-process the data? Because data is not in the right way. May not be the the right format, may not be the at the quality that's suitable for mining tasks. So we need to look to assess the accuracy of the data, whether the data values included in a data set, they are correct. Vast majority of them should be correct. If you have lots of errors in your data set, it is certainly going to skew your analysis. Completeness. Most of the data set we receive will not be complete. Some columns or features will probably have missing values, especially when the data is collected not through a mechanical way. In those cases, when the data is collected in real world for real phenomena, you will have missing values. For example, our police shooting data, we see last time that race has many missing values because the report did not mention the race. So when you collect that data, you will have that data cell empty. Completeness affects data mining a lot because some algorithms simply cannot work when you have missing values. So in those cases, you will either have to figure out a way to fill the value or remove the variable or observation. So those are difficult trade-offs. You don't want to lose information, but also, you cannot run this algorithm with missing information. So completeness is a major concern. Consistency is also a concern. especially when you have your data set merged from different sources. So you collected data from multiple sources and merged them into one. And then you will have to really check for the consistency. Sometimes the same variable might be included in two different sources, yet they're called different names. So you have redundant information. And other times you have the same attributes recorded, yet they're called different names. And maybe one is outdated, the other is more recent. So you even have conflicts in your data set. So those are consistency issues that you definitely want to check when you have multiple data sets. This integrating data sources from multiple places is called data integration. It's one of the research area in data mining because this task can be really challenging. Lots of active research. Timeliness. When your data mining task have a level of time sensitivity, you want to make sure the data that you have are up to date, right? So that's probably easy to understand. Believability actually is kind of, I don't think many people would think of this when we can talk about data quality. However, I do agree with the book that this believability is really a major factor. As a data analyst, if you don't trust the data that's provided to you, then when you perform data mining tasks, your interpretation of your results can be really wild. There are so many hypotheses that you will want to test. You're probably going to spend a lot of times to do lots of correlation to see whether the data actually makes sense before you actually perform anything that you to achieve your goal of the mining. You would question, well, can I trust this result? Maybe the issue with the data actually make this result, and the result is artificial. So the believability is a concern. Lastly, interpretability. Talk about how easy the data can be understood by you, the data analyst. This happens when the data is not collected by you or collected through a process that you're familiar with. Sometimes you will receive data that has like column names that doesn't make any sense to you. I really like some of the examples that they have this observation and then feature 1, feature 2, feature 3. It gives you no semantic information to see which feature is more important than others. They're labeled feature 1, feature 2, feature 3. Okay. So not being able to understand the data is a major concern. It's almost impossible for you to perform any deep analysis in the data and understand your result. So all of those are concerns. All of those need to be checked. However, we should also know that you will never get a perfect data set for any real data mining tasks. So we will do what is possible to make the data suitable for a mining tasks, but also understand that even without perfect data set, we still most times can get something useful from the data set. So now we have a basic understanding of the data quality, and next we want to look at the data format. So you have a set of data. How you're going to format the data going to make a difference on what data mining algorithms or methods that you could use. because in R later you will see that, for example, association rule mining requires data to be in transaction format. So you will have to convert your data from the original format to the transactional format. However, one fundamental format that used widely and also make a lot of sense, and also make it easy for you to convert to other format is called tidy data. So tidy data has 3 properties. Those are very intuitive, and you can tell from this example, tidy data is exactly probably the data format you would think that's natural for any data mining tasks. So it says each variable forms a column, right? Variable, and each observation forms a row. This is exactly what we have in the police shooting example, right? And each type of observational unit forms a table, which basically means in one table, the observations have to be of the same kind. So here we have a people, then the second one is also a person. You cannot have a person, a car, a dog, right? It doesn't make any sense. So the tidy data provides a standard way to structure data that can be easily used for many mining algorithms. They expect a format like this. And also it's easy to extract different variables that you might need for certain methods. So from this one large base table, you can generate different versions of the subsets of data that fits your needs for certain tasks. So therefore, this is a very flexible format that you can also convert those things into different other format easily using R or Python or other standard data processing packages. In R, tidyverse package, the widely used the package for data cleaning, expect data to be in this format. So there's many tools that has been created and make it easy for you to run analysis or on this tidy data or convert tidy data to other formats that you would need. So we mentioned variables, and I'm going to draw your attention to these 2 examples. In this two table represents the same data set. They are using different format. In one of the format, specific subjects are considered variables. So you will have math, English, whatever that follows. So my son is in 6th grade and he has 14 subjects. Okay, so you can imagine if we list those 14 subjects, this table will be very long. So this is a wide format. You could also use at a different level of abstraction, a higher level of abstraction, using subject as a variable. And then you will have different subjects as a value in this variable. So this is considered the long format, right? So you can see no matter how many subjects you have, I'm only going to have these 3 columns, okay? So this is depending on the mining task, you might sometimes find this, for example, compare student performance on different subjects. This might be the format you want to choose. On the other hand, you will notice that adding a subject creates a new column. And here, adding a subject doesn't affect the original structure of the 3 things. Okay. So I just want to draw your attention to those 2 formats. Depending on the mining tasks, maybe one is better than another. But they all fulfills the tidy data requirements if you consider math and English are variables. So I'm going to stop this video and start a new one. Or should we go on? Yeah, why don't we go on? To talk about the major tasks. In data pre-processing, data cleaning, right? So we mentioned filling missing values. And we also mentioned before that the data can be noisy, and there are methods that we can smooth out the noisy data, sometimes reverse the unwanted variation in the data. Those may be systematic systematic errors in measurements, or other things that does not add value but creates distractions. So we have methods to smooth noisy data, remove or identify outliers. Some analysis, as we're going to see, are very sensitive to outliers. So if you can identify and remove those outliers, maybe using box plot, for example, that will be very, very helpful, not to skew your mining result, because some algorithms are very sensitive to outliers. And resolve inconsistencies. So data cleaning basically address much of the issues that we have in data quality. And also data integration. So we also mentioned data quality slides, we mentioned consistency and redundancy. So when we integrate data from multiple data bases or data cubes or files, it could create certain problems, and that we need to address. Data reduction is also needed when you have a super large data set. A large data set could mean that you have a lot of features. So you have many columns when we're talking about the tidy data format. You have a lot of columns. Having a lot of columns have a problem of the curse of dimensionality that we're going to discuss. That a lot of algorithms will stop functioning, well, they will not perform well when you fit too many dimensions to it. In general, most algorithms deteriorate when the data dimensions increase beyond a certain level. And we're going to explain why that's the case. So it's highly desirable when you have super large dimensional data that you want to reduce the dimensionality. And the second aspect of a large data set is you have too many observations. As you can see, well, a lot of observation typically is a good thing. It allows you to learn information about different features. The matter of fact, the larger number of dimensions you have, the larger number of observations you will need. However, sometimes those dimensions, the number of rows, numerosity means number of observations. They are just too many that the machine cannot handle it. You cannot load the entire dataset into the memory of any machine or in the grid to perform efficient analysis. In those cases, we need to reduce those numerosity by either using sampling or clustering, different methods that we're going to introduce. Lastly, data transformation is one typical task that we perform. I don't see any mining task does not involve some sort of data transformation. Normalization is something we mentioned before. Recall last week we standardized SAT and ACT score. When your data set have attributes that measured at different units that are not standardized, you run the risk of giving certain attributes undeserved influence to your result. So data normalization is typically performed in data mining tasks. Normalization is also sometimes we can almost say required for certain algorithm to work. Unnormalized data and normalized data, when you fit to the exactly same algorithm, might give you very, very different result. Data discretization is a technique that we're going to discuss. It's also overlap with smoothing noisy data, and also concept hierarchy generation. This is one technique that used quite widely in data warehousing. It creates the opportunity, it enables the drill down and roll up operations that were mentioned before. So those three, we're going to cover all those three tasks. So I used the color, four. I used the colors, so this is 1, 2, 3, 4, right? So 4 different tasks. So I break them up into subtasks. And the methods that we're going to introduce later is also listed here. So I have those lines here connected to show you, in order to perform that discretization, what methods you could use. I hope this is going to provide you a way to organize your thoughts. Because some of the methods, as you can tell here, one method can be used for different purposes. Yeah, if you see a network of things starting to get blurry in your mind, come back and check on this little diagram. Okay, I'm going to conclude this video now.